According to the National Electrical Code, it is prohibited to install grounded receptacles on ungrounded circuits without a ground fault circuit interrupter or labeling indicating the absence of a ground conductor. Disconnecting ungrounded Romex in a metal junction box can be a violation of the NEC. Metal junction boxes must be grounded to provide a path for fault currents to return to the panel. Ungrounded Romex lacks a ground wire, which means that fault currents cannot safely return to the panel. Disconnecting a cable in a metal junction box without providing an alternate grounding path creates a hazard. In the event of a fault, current could potentially find a path through the metal box and into the ungrounded Romex, exposing occupants to electric shock or fire. One legitimate option for addressing this issue is to firstly disconnect the 3 ungrounded Romex runs from their corresponding junction boxes and run new grounded Romex to the receptacles. Secondly, ensure that all metal junction boxes are properly grounded by connecting them to the nearest grounding conductor. And thirdly, if the circuit does not have a ground fault circuit interrupter, install ground fault circuit interrupters on the newly grounded receptacles for additional protection. If the ungrounded Romex is a smaller wire size than the new grounded Romex, it is also necessary to upgrade the wire size to meet current code requirements. While it may be tempting to simply disconnect the ungrounded Romex, doing so without providing an alternate grounding path is a violation of the NEC and poses a safety hazard. The recommended approach is to run new grounded Romex and ensure that all metal junction boxes are properly grounded. When dealing with electrical systems, safety should always be the priority. Working with electricity can be dangerous, and it's always recommended to consult with a qualified electrician for any electrical work to ensure compliance with local codes and safety standards. If you encounter ungrounded circuits and wish to install grounded receptacles, it is crucial to address the grounding issue correctly to avoid potential hazards. Here's a breakdown of the considerations and steps you should take. Firstly, understand the code requirements. The National Electrical Code sets the standards for safe electrical installations. It's imperative to familiarize yourself with the relevant sections pertaining to grounding and receptacle installation. Generally, the NEC prohibits installing grounded receptacles on ungrounded circuits without proper ground fault protection or clear labeling indicating the absence of a ground conductor. Secondly, assess the existing wiring. Identify the circuits in question and determine the wiring type. Older homes often have ungrounded Romex which lacks a dedicated ground wire. Check the wire gauge to ensure it meets current code requirements for the intended load. If the existing wiring is undersized, upgrading it is necessary. Thirdly, evaluate the junction boxes. Pay close attention to the junction boxes where the ungrounded Romex is connected. Metal junction boxes must be grounded to provide a safe path for fault currents. If the junction boxes are not grounded, this needs to be addressed. Fourthly, consider grounding options. There are several ways to provide grounding for the new receptacles. One option is to run a separate grounding conductor from the receptacle to a suitable grounding point, such as a grounded metal water pipe or the service panel. Another option is to replace the ungrounded Romex with new grounded Romex, which includes a dedicated ground wire. Fifthly, install ground fault circuit interrupters. If running a new ground wire is not feasible, installing ground fault circuit interrupters is a code-compliant alternative. Ground fault circuit interrupters protect against electrical shock by detecting imbalances in the circuit and quickly cutting off power. Install ground fault circuit interrupter receptacles at the desired locations or use a ground fault circuit interrupter breaker in the panel to protect the entire circuit. Sixthly, label ungrounded receptacles. If you opt for ground fault circuit interrupter protection instead of grounding, clearly label the receptacles as GFCI protected and no equipment ground. This informs users that the receptacles are not grounded but are protected by a ground fault circuit interrupter. Seventhly, ensure proper connections. When connecting the new receptacles, follow the manufacturer's instructions and use appropriate wiring methods. Make sure all connections are tight and secure to prevent loose connections, which can cause overheating and electrical hazards. Eighthly, test the installation. After completing the installation, test the ground fault circuit interrupters to ensure they are functioning correctly. Use a ground fault circuit interrupter tester to simulate a ground fault and verify that the ground fault circuit interrupter trips and cuts off power. Ninthly, document the work. Keep a record of the work performed, including any modifications to the wiring or grounding system. This documentation can be helpful for future reference and for demonstrating compliance with electrical codes. 10thly, seek professional assistance. If you are not comfortable working with electrical systems, or if you have any doubts about the safety of the installation, consult with a qualified electrician. A professional electrician can assess the situation, recommend the best course of action, and perform the work safely and correctly. Remember that electrical work can be dangerous, and it is essential to prioritize safety at all times. By following these guidelines and consulting with a professional when needed, you can ensure that your electrical system is safe, code compliant, and provides reliable power for your home. Now, let's delve into some additional aspects of dealing with ungrounded circuits and metal junction boxes. Firstly, understanding fault currents. Fault currents occur when there is an unintended path for electricity to flow, such as when a live wire comes into contact with a grounded surface or a metal enclosure. In a properly grounded system, the ground wire provides a low impedance path for fault currents to flow back to the source, tripping the circuit breaker and quickly cutting off power. This prevents electrical shock and reduces the risk of fire. Secondly, grounding metal junction boxes. Metal junction boxes must be grounded to provide a safe path for fault current. This is typically achieved by connecting a grounding conductor to the metal box and bonding it to the equipment grounding system. The grounding conductor can be connected to a grounding screw inside the box or to a grounding lug on the outside of the box. Thirdly, addressing ungrounded Romex. Ungrounded Romex lacks a dedicated ground wire, which means that fault currents cannot safely return to the panel. This poses a significant safety hazard, as fault currents can energize metal enclosures and create a risk of electric shock. To address this issue, there are several options, as mentioned earlier, which include running a separate grounding conductor, replacing the ungrounded Romex, or installing ground fault circuit interrupters. Fourthly, exploring running a separate grounding conductor. Running a separate grounding conductor involves installing a new ground wire from the receptacle or junction box to a suitable grounding point. This grounding point can be a grounded metal water pipe, the service panel, or another approved grounding electrode. The grounding conductor must be properly sized and connected to ensure a low impedance path for fault currents. Fifthly, delving into replacing ungrounded Romex. Replacing ungrounded Romex with new grounded Romex is the most effective way to ensure a safe and code-compliant electrical system. This involves removing the old ungrounded wiring and replacing it with new wiring that includes a dedicated ground wire. The new wiring must be properly sized and installed according to code requirements. Sixthly, elaborating on installing ground fault circuit interrupters. Installing ground fault circuit interrupters is a code-compliant alternative to grounding in certain situations. Ground fault circuit interrupters protect against electrical shock by detecting imbalances in the circuit and quickly cutting off power. Ground fault circuit interrupters can be installed at the receptacle or at the circuit breaker panel. Seventhly, reviewing code compliance. When working with electrical systems, it is essential to comply with all applicable codes and regulations. The National Electrical Code provides detailed requirements for grounding, wiring, and receptacle installation. Consult the NEC and local codes to ensure that your electrical work is safe and code compliant. Eighthly, considering professional inspections. After completing any electrical work, it is a good idea to have it inspected by a qualified electrical inspector. An inspector can verify that the work was performed correctly and that it meets all applicable codes and regulations. This can provide peace of mind and help prevent future electrical problems. Ninthly, emphasizing safety precautions. Always take appropriate safety precautions when working with electricity. Turn off the power to the circuit before working on any wiring. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and rubber gloves. If you are not comfortable working with electricity, consult with a qualified electrician. 10thly, understanding the importance of grounding. Grounding is a critical safety feature in electrical systems. It provides a path for fault currents to flow back to the source, tripping the circuit breaker and quickly cutting off power. This prevents electrical shock and reduces the risk of fire. Properly grounded electrical systems are essential for protecting people and property from electrical hazards. Therefore, when faced with ungrounded circuits and metal junction boxes, it is imperative to address the grounding issue correctly to ensure a safe and code-compliant electrical system.